Hi everybody, in this chapter we're going to be talking about simple machines, which is going to be an application of conservation of energy, which is something that we talked about in the previous chapter. So here are your list of formulas, or your list of variables first, and down here are going to be the formulas that you'll be using. It looks like there's a lot, but there's really only three basic formulas here. So let's go right into it. So the purpose of a lever is, well, the first simple machine that we're going to be looking at is a lever. And the purpose of a lever in all simple machines really is to amplify the force that you apply. So let's say that this is a boulder here, and the boulder is the thing that you want to lift. I'm going to call it, it's going to have a weight. So I'm going to call it the load, or F load. That's the thing that you want to lift. And you yourself, what you're trying to do is you come next to the boulder and you exert a force to lift it. So you exert your own force. And I'm going to call this the applied force. I'll just call it applied for now. But the thing about it is that the boulder is a lot bigger than you are. So typically the force that you apply is not big enough to lift the boulder. So what you want to do is find a way to amplify or magnify the force that you apply. And that's gonna, so we're gonna use a simple machine to do that. And the first simple machine is gonna be the lever. So let's see how the lever or the lever is set up. So what you're gonna do is you're gonna take a pivot point, or what's called a fulcrum. Just try this a bit more clearly. So you're gonna take a pivot point, and what you're gonna do is you're gonna set up and you're gonna take a plank, and you're gonna set up the plank like this, so that there's a long end, and then there's a short end. Like this here. And you're gonna place the boulder, the bottom of the boulder, on the short end. So the heavy thing that you want to lift, you're gonna place it on the short end here. So this is the load that you want to lift, so I'm gonna call that one F load. That's the heavy thing that you can't lift by yourself, but you're gonna place it underneath this lever, so that the boulder is on the short end of the lever. So that's going to be this end over here. So the distance from the pivot to where you place the load, this distance here is called R load. So you're going to place the load on the short end of the plank over this distance R load here. And what you yourself are going to do is you're going to stand on the other end, on this far end all the way back here, and you're going to apply the force with your hands. And again, the force that you apply with your hands is very small, but if you apply it over this long distance here, which I'm going to call, and this distance is measured again from the fulcrum to where you apply your hand. So this distance here, I'm going to call it RA, or R applied. So when you do that, so that the load is on the short end of the lever and you apply a force on the long end of the lever, you're actually going to be able to lift up that load. And the reason why this works is because of conservation of energy, or actually in this case here, conservation of work. So the point is that you apply so you just try to kind of separate these two here. So this is the side where you apply the force, and this is the side where we're trying to, where the load is. We're trying the thing that you're trying to lift. So instead of calling it conservation of energy, we're going to call it conservation of work. So the point is that the work that you do on the applied side is going to equal the work that you do on the load side, or the energy on the applied side is the same as the energy on the load side. And the work on the applied side is equal to the force that you apply multiplied by the distance that you apply the force from the fulcrum, from this thing here, and that's going to equal the force of the thing you want to lift, or the load force, multiplied by the distance that you place the load, RL, from the fulcrum. So this equation tells you by how much you can magnify a force. And again, the point is that you set up a fulcrum with a plank with a long side and a short side. The heavy thing that you want to lift, that's going to be F load. You're going to place it over the short end here of the plank at some distance RL from the fulcrum, from this distance here. And you yourself, you're going to apply a force on this side FA, and you're going to apply it over this longer distance here from the fulcrum, RA. And that is actually going to be a way that you can magnify the force that you apply. So that's our first equation. So now let's look at this problem from another perspective. So you have the fulcrum. Well, you have the lever and the fulcrum here. And this is the machine. And so what's happening is that you apply a force with your hands, FA. And what you're able to do is lift up this heavy load that normally you wouldn't be able to lift, F load. I'll just say FL here. So what you can say is that this lever, what it did is that it magnified the force that you applied, because you're able to apply a small force with your hands but create a big force on this other side here to lift up this load. So you can see that the lever magnified your force. So we're going to look at it in terms of that. What we're going to say then is that if you apply a force FA with your hands, then onto this lever here, what the lever is going to do is it's going to magnify your force. And we're going to define that as this variable here called MA, or magnification, or really it's called mechanical advantage. And what that's going to do is it's going to create it's going to magnify your force to create a bigger force that's going to be able to lift the load force. So this is the force that you apply with your hands. And then this is what the lever does, or the simple machine. It magnifies your force by this much, so that at the end you're able to generate this amount of force here. So we have another way to look at, another formula to look at simple machines, is that it basically says that simple machines magnify your force. And this term MA here, this is by how much the machine magnifies your force. This is called the mechanical advantage. And that's another way of saying magnification. That's how much the specific machine is going to magnify the force that you apply. So we have two basic equations. The applied force multiplied by the applied distance is equal to the load force multiplied by the load distance. That's one. And we have this other equation that if you apply a force FA, the lever, or the simple machine, is going to be able to magnify your force to create a new force F, in order to lift the force F load. So those are two basic formulas. There's a third formula, but that one, is just doing some algebra. If you plug in this formula into this one there, then you get this third formula, which you don't really need to write it. You can just use those first two, but you can also write the magnification of the machine in terms of the distance is where you apply the forces. So there you get that the applied distance is going to equal the magnification of the simple machine, or the mechanical advantage, multiplied by the load distance. But again, you can get this formula just from these two here. So this is our first simple machine, which is a lever.